Solar panels are some of the best sources of clean energy, but they're inconsistent. They aren't available when it gets cloudy or dark. Other times, they can even make too much energy. Both of these can be destabilizing to the electric grid because they require quick action by fossil fuel generators. This inconsistency limits how much solar can connect to the grid, and Tumalow doesn't think solar should be limited. Pairing energy storage with solar can solve these problems. The challenge is to be cost-effective. In the next few minutes, we'll lay out how to achieve a cost-effective integration of energy storage and solar by organizing the storage into a network that generates revenue, reducing a building's peak load, and keeping the electric grid stable. We'll examine why schools are the best initial customers for these installations, and how we're involving them in the design process. And we'll finish by meeting the team that's going to make all this happen, which includes programmers, battery and solar experts, and a school superintendent. Many solar installations are covered under a power purchase agreement, or PPA, that lets a solar provider install panels at no cost to the customer and sell them the power. We extend the PPA to include energy storage. Tumalow's value proposition: reduce your electric bill at no cost. To start, we install battery energy storage at no upfront cost. It will be available to smooth out the solar generation, and we will use the storage to generate revenue in two ways. First, we reduce the peak load of the building. Buildings are hit with a demand charge based on the 15 minutes each month they use the most power. The energy used to set the demand charge costs hundreds of times more than energy used the rest of the month. Reducing this peak load by discharging the storage will reduce the electric bill. We collect one revenue stream by sharing in this savings with our customer. Reducing the peak load of the building will take less than 10% of the battery's time. The other 90%, we can generate a second revenue stream using the storage to stabilize the electric grid. The supply and demand for power on the grid needs to remain balanced at all times. The technical term for this is frequency regulation. Instead of destabilizing the grid, our combination of solar and storage actively stabilizes it, and will add more useful applications for energy storage in the future. But for this MVP, we'll focus on these: solar firming, peak reduction, and frequency regulation. To get the best possible use out of our energy storage, we'll connect each of these storage systems over the internet into a network that can use the storage more efficiently than any individual system acting alone. This core technology can work in many types of buildings, a total market worth over $22 billion per year in revenue just from operating the storage. To get started, we'll focus on the customer segment that benefits the most: K-12 schools. K-12 schools run on a tight budget. They can't raise taxes, and they can't cut salaries. Energy spending is one of the few things schools can cut without compromising the health or education of their students. Schools are already comfortable buying energy products like new lights using performance contracts, and energy service companies do exactly that with over 40% of the schools in America. They also use electricity in a peaky pattern, which makes it easy for energy storage to reduce their peak loads. The schools have been very enthusiastic about our product, and we're engaging them in the design process. This is Maple Hill High School. They've not only agreed to host our pilot site, but they're helping to write our energy storage PPA so that it will fit and not fight a school budget. We also found the best location for our launch. Our revenue streams come from reducing demand charges and selling grid services, so we systematically analyzed almost every electric grid in the nation, and alongside that, studied the market conditions for selling grid services across the country. The area with the best combination was in Virginia. We're close to a minimum viable product and have prototypes of all the major parts of the control system. If selected, we'll use the software development assistance for system integration to get our software working as quickly as possible. Our core team has strengths in building software to solve optimization problems and drive real-time controls. We've also assembled an advisory board that includes a director at the New York Energy Storage Consortium, the superintendent of a school district, and the CEO of a solar company. To wrap up, the problem was the efficient integration of energy storage with solar power. Our solution? A network of energy storage that generates revenue by reducing a building's peak load and keeping the electric grid stable. And the network starts in our schools by giving them a way to reduce their electric bills at no cost. With the efficient use of energy storage, we can take the limits off of solar energy.